All right, 2.6, some direct translation. So again, equations versus expressions. We're going to be writing both for this section, so it's important to understand the difference. Equations have equal signs. Expressions do not have equal signs. So just when we're translating the operations, addition, subtraction, multiplication, division, okay? These are some key words that we're looking for. We won't see all of them, but we'll see some of them, okay? Like you'll see added to, combine, deposit. And yes, it is possible we may need to add to this list, which we'll see. There's not a whole lot for divide, okay? Again, one of the main things we're evaluating with division is what the question is asking, and should be asking how many of something goes into something else. All right, so if we see this, we should interpret that as division, which we will see examples of. A quotient, of course, is just an answer to a division problem. And same with multiply, product, groups of. They say of is one of the key words. I don't know that it is because it kind of works in with division as well. Subtraction, these two at the bottom with the asterisks, we need to be very careful with those because these top ones are usually direct, so they translate directly. Like if I said 5 take away 3, that's 5 minus 3. But if I said 5 less than 10, that's 10 minus 5, which is a huge difference, okay? And again, we'll see those types of examples in the examples, but addition, it doesn't matter. Same with multiplication. Order does not matter for those because the property of, the commutative property of multiplication makes it so that the order doesn't matter for those two. But order definitely matters for division and subtraction, particularly when we see these two forms of wording in these problems, okay? So keep that in mind. When we see these two, we may have to spend a little bit more time on those because they're not direct translations. Now, for the most part, we'll see x as the variable, okay? So on this one, there's two ways to write it that are both correct. This one says 22 more than a number. Now, if it said less than a number, there would only be one answer. But with addition, because it's more than, right? More means that we're going to add. The order does not matter. So you could say, well, I'm going to take 22 and add some number. And x, again, for the most part, we're going to be showing as the unknown value. So 22 plus x would work. But if you said, well, it's some value, but 22 more than that, that works too. Again, because order for addition does not matter. So this is, this one's saying subtracted from, and this is one of our key or one of our unique situations with subtraction. This is not 16 minus some number because we have to subtract 16 from the number, okay? So we need to switch this up and show it as the number, and we're going to subtract from that number 16. So again, even though this section is called direct translation, we have to be careful, particularly with subtraction and later on with division as well. All right, Jack is 4 centimeters taller than Susie. Write an algebraic expression for Jack's height. Well, Jack's height is going to be represented in relation to Susie's height, right? So I'm going to define this, not that you'd have to, but it's a good practice to get into. So I got Susie's height. I'm going to say that Susie is going to be represented. You know what? I'm not going to use the letter S because it kind of looked like a 5. I'm going to say it's going to be represented by X. So X represents Susie's height. Well, Jack's height would be Susie's height, but he's 4 centimeters taller, right? So I'm just going to say Susie's height plus 4. And no, we do not need labels in the expression. I mean, if we were to solve an equation, not that this is. This is only an expression, so I can just write it like this. And that is all I would need. Now, it is possible on the homework they may say, use a specific letter for Susie's height. Make sure you use that letter when you're typing those answers in. Now, we just got finished with 3 sections of solving equations. But this is only expressions, right? It said write an algebraic expression. Since it said specifically an expression, we don't want the equal sign. We're not actually solving anything on these ones. We're going to solve equations, but for now, when it says expression, you have to be satisfied with the way that it is, x plus 4. All right, Jan bought W video games for $14 each. Write an algebraic expression for the total amount Jan spent. All right, so this is one of those where it tells us what letter to use specifically, right? Now, if Jan had just simply bought one video game, it would have been W video games, right? And how much would that have costed? It would have been 14 bucks. But if let's just look at the pattern here, right? So if Jan buys 2 video games, 2 times 14 would be the total. If Jan buys 3 video games, 3 times 14, right? Because it's $14 each. So really all we're doing is taking the number of video games and multiplying it by how much each of them costs, which is $14. So 14 times W would tell us how much Jan has spent, depending on how many video games, of course, that Jan purchases. But this expression would be good enough to tell us the cost based on how many video games Jan buys, purchases, whatever. So a little bit more words in this problem, that's okay. Miss White and Miss Brown were driving to a conference 340 miles from their work. Miss White drove the first D miles, that's our first variable right there, the D. Then Miss Brown drove the rest of the way. Write an algebraic expression, that should say for typing's hard. I like froze though. How many miles Miss Brown drove? Okay. Yeah, sorry about that. Well, here's the thing is, we know how many total miles they're going to drive altogether, right? And looks like Miss White drove a certain amount, Miss Brown drove a certain amount. And a diagram may be helpful in a situation like this. It'll definitely be helpful in the next section. So if I said this was the total distance, this line represents 340 miles. And how far did Miss White drive? Well, Miss White, which we'll show in purple, is going to drive D miles, right? So this is Miss White. And then Miss Brown, I don't know if I have a brown color on this one. It's pretty brown. This is Miss Brown. Let's use a capital B right there. Well, we want an algebraic expression for how many miles Miss Brown drove. Well, Miss Brown is going to drive whatever's left of the 340, right? So we got to take the 340, and of those miles, the 340 miles that they all drove, how many did Miss Brown drive? Well, we'd have to take away the amount of miles that Miss White drove. So 340 minus D, that's Miss White's miles, would tell us how many miles Miss Brown drove. So this would be the expression which would represent how many miles Miss Brown drove. This is also the same as asking what the difference is between how much they drove and Miss White's driving distance. All right, translating equations, we're going to be using all the same translations for addition, subtraction, multiplication, division. But equals, okay, is usually represented with the word is. From time to time, it will be just said outright, it equals to, maybe equivalent. We will see this from time to time as well, results in. That, where these words go in the translation of these problems, these word problems, is where the equal sign goes. But again, for the most part, we'll see is in these problems. So not only are we going to translate these equations, we're also going to solve them. It says to use x as the variable. So it says 38 less than a number. So there it is. That we said would see it less than, right? So it's 38 less than a number is, there's another keyword, negative 76. Okay, so is representing the equals. Less than means we're subtracting, but we need to switch the order of the values they gave us. So it's 38 less than a number. And they did tell us to use x as the variable, so that's the number we don't know. X minus that 38 right there. At 38. Now this is negative 76, so negative 76. And this is the equation that we need to solve. Well, we'll just step back one section, and we know we need to zero out that negative 38 by adding 38 to both sides, which does zero that out. So we'll drop that x. It's really 1x if you want to show it as 1x. I'm not going to, it's fine. Negative 76 plus 38. Uh-oh, let me see. I know it's got more negatives than positives. 76 minus 38. Oh, that's an 8. So there's an 8 and 38. Oh, I didn't expect that. Negative 38. So what is the number? Negative 38. Same thing on this one. We use x as the variable. 6 subtracted from 10 times a number is 54. So subtracted from, again, that's one of those key subtraction phrases, which means the order is different. And there's our is, so that's our equal sign. So 6 subtracted from 10 times a number. So I got 10 times a number, which is shown as 10x. And from that, we're going to subtract the 6. And then this equals 54. That's nice. All right, so this is a two-step equation. And solving this one out, I'm going to zero out that negative 6 by adding 6 to both sides. That's going to work out very nice. That zeroes out. We'll drop the 10x. 54 plus 6 is 60. And then divide by 10 tells us that x equals 6. So what is the number? 6. All right, now there's two parts to this. It looks pretty much the same for these two, okay? I'm going to read both of them. And yeah, we'll use x as the variable. But A, 8 times the sum of a number and 4 is negative 192. Part B, the sum of 8 times a number, the sum of 8 times, I should say a number, and 4 is negative 196. There's a huge difference between these two, and they're going to look very different, and they're going to solve very different. But let's look at these one at a time, all right? So part A, 8 times the sum of a number and 4. So it's 8 times the sum. So we got to take the sum first. So the sum is addition. What is it the sum of? Well, it's the sum of a number and 4. So x plus 4. Now it's 8 times that. It's 8 groups of that. 8 groups of that. So we got to keep that in parentheses. This is a distribution problem. If you ever get 8 times or sometimes the sum or sometimes the difference, it's a distribution problem, okay? And again, we'll look at the difference in part B, but let's finish this one off. So it is, so there's another one of our keywords, that's equals negative 192. So now we'll distribute the 8. We're going to solve this, right? So we got 8x, 4 times 8 is 32, equals negative 192. Let's zero out that 32, so we'll subtract 32 from both sides. Hope I have enough space here. 8x equals negative, there's 4 and 12, 224. And then we'll divide both sides by 8. So now we'll say x equals, I know it's negative, and then 224 divided by 8. 8 goes into 22, that's 2 times. So there's a 16, and then 64, that's 8 right there. So that's a negative 20. That's a 0 remaining on that one. But yeah, the number on this one is negative 28. So let's go to part B then and consider the difference, okay? So part A, 8 times the sum. B is the sum of 8 times the number. So we got to do 8 times the number there, which is 8x. And it's the sum, so that's addition. Sum with 8x and 4. And there's the keyword is, that is negative 196. So now we have this equation, which we can solve. So I need to zero out that plus 4. So subtract 4 from both sides. That goes into that evenly, but we'll find out. And then what do we got? We got to make that a 1x, so we'll divide both sides by 8. Yeah, it's not going to go into that evenly. Let's see. 200 divided by 8. That's 2, 16, 40. Oh, it does. I'm sorry. That's a negative 25. And again, don't forget that negative on the answer. But that would be the answer to part A, answer to part B. So again, I just want to emphasize that the way these are worded will determine if you need distribution, or in part B if you don't.